Good morning, children. So we are from Aspire Gate NEET Coaching Center, NEET and JE Coaching Center. So we are started with the D block elements. So I'm going to deal you with chemistry. So I'm going to start. Already have started with the D block elements, and we are studying about the D block elements. So in the D block elements, the first and the foremost important things are the properties. So which is a very expected questions in your CBSE examination. You will get one 3-mark question. Even in your NEET as well as in JEE also, you will be getting the questions from the properties of D block elements. So when you talk about the properties of the D block elements, as I've already told you, totally there are 10 properties in the D block elements. So we have to study 10 properties separately. So what are all the properties, and what is the reason why the D block elements exhibiting such a property, and what are all the examples. So property names, 10 property names in a tabular form, we have to study the properties name, and then what is the reason behind that property, and then we have to give an example. Without example, we should not write or board examinations. And even in your NEET and JEE competitive examinations, even in your CUET examinations, you may expect a questions from the reason based, why the D block elements exhibits variable electrode potential, why it forms the colored ions, what is the reason the D block elements exhibits a catalytic properties, why it forms alloys, the reason behind, because the D block elements has a unique feature. And these D block elements, when you take, it has been placed between S and P block elements, between metals and non-metals. The D block elements have been placed, so that is why the properties of the D block elements are transitional in nature. The properties are transitional. Sometimes it acquires the properties of metals, and even it acquires the properties of the non-metals. Why it is happening for D block elements alone? That is because when you take the periodic table, this D block element has been placed in between S and the P block element. So that implies the D block elements acquiring the characteristic properties of metals as well as the non-metals. So totally there are 10 properties. So we have started already with the properties, and you please keep watching our video regularly. This is from Aspire Gate NEET and JEE Coaching Center, which is situated in Adayar, Chennai. So please do watch, and every day we will be telecasting the videos, and it is your foremost responsibility. Observe, this is free of cost. You can see, and I will be giving you the notes, and please keenly observe my lecture and take down the notes, which will be very much helpful for you. And today we will start with one of the properties, foremost important properties, and this property which we would have studied in the coordination compounds as well. That property is color formation. The D block elements, so color formation, color formation. So when you take this D block elements, this D block elements will form colors. The D block elements or the ions will form the colors. So D block elements forms colored. It has a colored ions. It has a colored ions. எப்பப்பெல்லாம் when it will form the colors அப்படின்னு பார்த்தனா, when this metal ion combines, or when this metal ion is combining with a solvent, forming a solution, that time it forms color. The metal ion, the D block metal, totally how many elements are there in the D block elements? Totally 40 elements are there. And when you take these 40 elements, when it is going to be in its oxidation state or ionic state, that time if it is going to be getting mixed with a solvent, a suitable solvent, then it will come to a solution. Such circumstances, it forms color. And similarly, when this metal ion, I mean the D block elements, metal ion from 3D series, 4D series, 5D or 6D series, whatsoever it is, that metal ion, when it is going to combines with a ligands, when it going to combines with the ligands or the electron donor, this we would have studied from coordination compounds. So ligands or the electron donor, it forms a complex. It forms a complex. Or otherwise we can call it as a coordination compounds, or otherwise we can call it as what? A coordination compounds. Such circumstances also, the D block elements or the ions, will form a color. Will form a color. Suppose when these d block metal ions are going to exhibit as a crystal lattice, if it is going to exhibit in the form of a crystal lattice, a lattice structure, interstitial compounds like, so lattice structure, crystal lattice, then obviously such times also it produces color. So colors are possible. So when the metal ions will exhibit the colors, or whenever the metal ion are going to combine with the suitable solvent forming a solution, and similarly whenever the metal ion is going to combine with the ligands forming a complex, whenever a metal ion is going to form a crystal lattice, such circumstances we can expect a beautiful color formations. This is the introductory part. Now we go to the reasons why the d block elements forms colored ions. The reason for the formation of colored ions, formation of colored ions. Let us see what is the reason for the formation of what? For the formation of colored ions. The first and the foremost reason is DD transition. The first, I will explain you what is this DD transition. The first and the foremost reason is DD transition. Now, coming to the second point, due to the presence of unpaired electrons. Due to the presence of what? We can say due to the presence of unpaired electrons. First explanation, we will see what is this DD transition. When you take this d orbital, the full form for d is degenerate orbitals. It is otherwise called as degenerate orbitals. When you take this d orbital, it will be having 5 orbitals, 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. So it will be having how many orbitals? Totally it will be having 5 orbitals. 1, 2, 3, 4 and 5 orbitals will be present. And when you take these 5 orbitals, these 5 orbital exhibits with equal energies. All these 5 orbitals are existing with equal energies. So reasons I have said, one is DD transition, the other one is due to the presence of unpaired electrons. Now I am explaining the reason. The first reason is what? DD transition. So for that I am giving you an explanation. What is meant by DD transition? For that I am giving you the explanation. There the first point is the d orbital means degenerate orbitals. That means the d orbitals will undergo splitting, or otherwise we can call it as degeneracy. It can undergo splitting or otherwise degeneracy, we can say. So when you talk about this d orbitals, there are totally 5 orbitals, and these 5 orbitals are existing with equal energies. What are those 5 orbitals? We can name them. That is dxy is the first orbital, then we have dyz, then dzx, then dx square minus y square, then dz square. So totally how many orbitals we have? Totally 5 orbitals we have, isn't it? This is the name of these 5 orbitals. Now this d orbitals, when you talk about these d orbitals undergoes degeneracy. It undergoes what? It undergoes degeneracy. Degeneracy means splitting. The d orbitals will undergo what, ma? It undergoes splitting. Due to the effect of photons from the visible spectrum, or due to the light, or otherwise even due to the approach of ligands. Due to the approach of ligands, these d orbitals will undergo degeneracy. So again I will continue from the first. What we are studying? We are studying about the properties of the d block elements. Under the properties of d block elements, the first property is the color formation. Today's first property is color formation, which we are studying. When you talk about these d block elements, it always forms colors. The 40 elements are there based on its oxidation state, based on the number of valence electrons present on the inner penultimate shell. These d orbitals will form the colors. When it will be forming a color? Whenever it is going to combine with a suitable solvent, whenever it is going to be forming a complex by taking the electrons from the electron donors like ligands, and finally when it is going to give a lattice structure, a crystal structure like crystal structure, it will be forming the colors. So what is the reason behind the color formation? The first reason is dd transition. Due to dd transition. Second one is due to the presence of unpaired electrons. So first I started giving an explanation what is meant by dd transition. So dd transition, before we are getting into the dd transition, first we must know what is the full form for this d. Why d name has been given? D name has been given for that particular group of elements of 40. So the d stands for degeneracy. Degeneracy means what? Splitting. Degeneracy means those 5 orbitals will undergo splitting. When it will undergo splitting? Whenever it is going to be approached by a ligand, maybe a strong field ligand or otherwise a weak field ligand. Sometimes when it is being stimulated by the high energy or high frequency photons, or light sensitivity also plays a significant role, out of which these d orbitals will be undergo degeneracy. So now see how this d orbitals is undergoing degeneracy. Hope you can understand. You would have written all this. Now what is this degeneracy? How d orbitals is undergoing degeneracy? We will see the examples. I told you for color formation there are 2 reasons. One is dd orbitals degeneracy, isn't it? dd transition state or dd degeneracy state. The second one is due to the presence of unpaired electrons. Now I am going to explain. Already I have started explaining about the d orbitals is undergoing degeneracy. That's what I have given. I have taken d4 system. So this is the d orbital. Now listen carefully. So this is a d4 system. What is that 4? 4 is the presence of unpaired electrons. So with inside the bracket I have given the numbers. This implies the number of unpaired electrons. How many number of unpaired electrons were present here? If I am going to talk about a system, d4 system, that implies this 4 implies what? The number of unpaired electrons. So totally how many unpaired electrons in this example which I have taken is 4. So now I am going to fill 4 electrons. I have filled 4 electrons, isn't it? Now this d orbitals, when you take, it undergoes degeneracy, splitting 3:2. The ground state configuration. This is a ground state and this is an excited state. In the ground state, 3 orbitals will be present, which is called as T2G. In the excited state, there are 2 orbitals which we call it as EG. What is this T2G? T2G is called as triply bonded d orbitals. Triplet we can say, or otherwise triply bonded d orbital. Triply bonded d orbital. What is this EG stands for? EG stands for doubly bonded d orbital. Triply bonded d orbital. The other one is called as doubly bonded d orbital. So d orbitals, triply bonded d orbitals. So in the ground state you can see 3 orbitals were found, and in the excited state you can see 2 d orbitals were found. Now take out those 4 electrons. What happens is here 1, 2, 3 and 4 electrons I have filled here. Okay, 4 electrons. This is now the configuration we have. So T2G, what is the configuration? 4 electrons, and EG we don't have any electrons. So EG have written 0. Now what happens is, as I have already mentioned, as I have already told you, what did I say? These d orbitals exist with equal energies, similar energy level, equal energy level. Each orbitals will be having what? Similar energy, equal energy, more or less similar energies it will be having. Okay, so since it will be having a similar energy, the electrons which is present in the ground state will be getting excited to the higher energy level. That is, it is getting excited to the it is getting moved, or it is getting drift, it is getting shifted. Where it is getting shifted? It is getting shifted to the excited state, from the ground state to the excited state. When it is getting excited, automatically this electron is doing some work, isn't it? The electron is moving, the electron is not stationary, the electron is getting excited. When the electron is going to get excited, that means the electron is doing some work. For doing that work, that electrons requires some energy. That energy is being taken from the absorption spectrum of the visible light. Okay, so with this electron, by taking the energy, from where it is taking the energy, so I am mentioning it as an energy. Where it is taking the energy? The energy is being taken from the absorption spectrum. It is being taken from absorption spectrum, from the absorption spectrum of the visible light, not from UV light. ஆனா இந்த எஸ் பி ஆர்பிட்டல்ஸ்ல இருக்கக்கூடிய எலக்ட்ரான்ஸ் எக்ஸைட் ஆகும்போது அதுல ஈக்குவல் எனர்ஜி இருக்காது அந்த ஆர்பிட்டல்ல. ஸோ வென் த எலக்ட்ரான்ஸ் ஆர் கெட்டிங் எக்ஸைட்டட், எஸ்லயும் பிலையும் whenever we see those electrons, when it is moving or getting excited, அங்க நான் வந்து ஸ்பிளிட் ஆகும்னு நான் சொல்லல அந்த ஆர்பிட்டல். ஆனா எலக்ட்ரான்ஸ் மூவ் ஆகும்போது அதுக்கு தேவையான எனர்ஜியை எடுக்கும். இட் வில் பி டேக்கிங் இட் ஃப்ரம் தி அல்ட்ரா வயலட் ரேடியேஷன். ஆனால் டி ஆர்பிட்டல் இருக்கக்கூடிய எலக்ட்ரான்ஸ் மட்டும் தான் விசிபிள் லைட்ல இருக்கக்கூடிய அப்சார்ப்ஷன் ஸ்பெக்ட்ரம்ல இருக்கக்கூடிய எனர்ஜியை கிராப் பண்ணி அப்சர்வ் பண்ணி it will be getting excited. So, okay, now this electron from the absorption spectrum, it takes the energy and it goes here. Okay, so now electron has come to the excited state. So when this electron comes here, it feels that it is lonely or instability prevails. So in order to attain the stability, once again this electron comes back to the original state, original ground state. When it coming back to the original ground state, what happens is actually the amount of energy being absorbed from the absorption spectrum, same amount of energy will be getting emitted into the emission spectrum of visible light, into the emission spectrum. Again I repeat you, listen carefully. So the electron goes to the excited state. Since there is a vacant d orbital in the higher energy level, so electron is getting excited. When it gets excited, that shows that it has performed some work. For work to be done, it needs some energy, so it takes the energy from the absorption spectrum of the visible light. When it goes to the excited state, it feels the instability. As a result, the electrons from the excited states comes back to the ground state. When it coming back to the ground state, the amount of energy which is being absorbed, the same amount of energy will be getting emitted into the emission spectrum of the visible light. Clear? Now this electron has come down. Here one more very important is, whenever electron is getting excited, I said it absorbs the energy from the absorption spectrum. Not only it absorbs the energy, but also it absorbs color. ஏன்னா அந்த எலக்ட்ரான் எனர்ஜி எங்க இருந்து அப்சர்வ் பண்ணுது? விசிபிள் லைட்ல இருந்து அப்சர்வ் பண்ணுது. விசிபிள் லைட்ல இருந்து எனர்ஜி அப்சர்வ் பண்ணும்போது கண்டிப்பா கலரையும் சேர்த்து அது என்ன பண்ணணும்? இட் அப்சார்ப்ஸ் கலர். ஏன்னா அது விசிபிள் ரீஜன், இட் அப்சார்ப்ஸ் த கலர். So color with energy, it goes to the excited state. திரும்ப அந்த எலக்ட்ரான் அன்ஸ்டெபிலிட்டினால கிரவுண்ட் ஸ்டேட்டுக்கு வரும்போது எவ்வளோ எனர்ஜி அப்சர்வ் பண்ணதோ அந்த எனர்ஜி எமிஷன் ஸ்பெக்ட்ரத்துல இட் இஸ் ரிலீசிங். அண்ட் சிமிலர்லி என்ன கலர் அதை அப்சர்வ் பண்ணி எலக்ட்ரான் இஸ் கோயிங் டு த எக்ஸைட்டட் ஸ்டேட், அந்த கலருக்கான காம்ப்ளிமெண்டரி கலரை அது லிபரேட் பண்ணும். Not only the energy is getting liberated, but also the color which is being absorbed, and the color அப்படியே complementary color, opposite color, complementary color will be getting liberated. That complementary color only we are seeing. What is that complementarity? Visible spectrumல இருக்கக்கூடிய colors என்னென்ன? See, VIBGYOR, isn't it? VIBGYOR, VIBGYOR. Now see, violet. Usually this indigo we will not consider. ஏன்னா absorption spectrum, emission spectrum அதோட frequency nanometer ஓட range பார்க்கும்போது absorption spectrum, emission spectrum ரெண்டுத்திலுமே ஒரே கலர் தான் வரும், indigo. So we will leave that. Then we have blue, green, white, yellow, orange, and then red. Now we will write absorption spectrum, emission spectrum, la color. In the emission spectrum la varakudiya color only we can see, we can visualize. Suppose if in absorption spectrum violet color and the electron absorb பண்ணி மேல போனா அதுக்கு complementary color is yellow color. So அப்ப நம்ம yellow color பார்க்கறோம்னா அது ஒரிஜினல் yellow இல்ல, யாருடைய கலர் அது? ஒரிஜினல் கலர் இஸ் violet. Violetோட complementary தான் நம்ம yellow color பார்க்கறோம். Similarly, when you take blue, அதோட complementary color is orange. Green oda complementary color is red. Green oda complementary color is what? Red. So this is the absorption. If the absorption spectrum, if the electron is going to take the violet color, then in the emission spectrum we will be getting yellow color. Blue, then complementarity of blue is orange. Green, then the complementarity of this green is red. Okay, so the first reason what I said, due to the splitting, dd orbital oda splitting, dd transition state. Now the electron split at d orbital, since the d orbital is undergoing splitting, then only what has happened, the electron has gone to the excited state. Base reason enna, the d orbital இப்படியே இருந்ததுன்னு வெச்சுக்க, if the d orbital is not undergoing a degeneracy, if it is going to remain as such, same as like this, then obviously no question of transition or excited state. Absorption, emission எதுவும் வராது, electron transmit ஆகாது, excited state போகாது. ஆனா இங்க என்ன ஆயிருக்கு, இந்த d orbital split ஆயிருக்கு, split ஆனதுனால degenerate ஆயிருக்கு, அதனால the electrons என்ன ஆகுது, ground stateல இருந்து excited state போகுது, excited state போகும்போது what's happening, energy absorb பண்ணுது, absorption spectrum of the visible lightல இருந்து கலரையும் சேர்த்து absorb பண்ணி it is going. When the electron goes to the excited state, it feels that it tends to be unstable, so therefore the electron which is present in the excited state is coming back originally to the ground state. அப்படி ground state திரும்ப அது வரும்போது how much amount of energy has been absorbed has been getting emitted along with the complementarity of the color. Whatever the color that has been absorbed, that is complementary color. How to find out the complementarity only I have mentioned it here. Okay, so this is the first explanation. And second point which I have told is due to the presence of unpaired electrons. Now see, for this I have given you some examples of unpaired electrons. In your competitive exams I will ask you why this Se3 plus Se3 plus scandium 3 plus oxidation states tends to be colorless. Why Cu plus is colorless? Why Zn2 plus is colorless? Colorless, color main reason in a presence of unpaired electrons. So you have to write and you have to check, see whether there is a presence of paired or unpaired electrons. Now Cu2 plus, if I am going to take an example, Cu2 plus, atomic number is 29, nearest noble gas configuration is argon, so that becomes 18. Then we have a valence shell, that is 4s, and penultimate shell is D, isn't it? So valence shell and penultimate shell. So 18 electrons already have filled, and remaining how many electrons were there then? 9 plus 2, 11 electrons were present. So first let me, you know this copper exhibits anomalous electronic configuration. Here we cannot write 2, instead I have to write 1, and here it becomes 10, isn't it? This is the configuration of this copper. Provided if it is going to be 2 plus oxidation state, then 1 electron I have to remove from here, from the valence shell, and from here also 1 electron I have to remove. If I am going to remove, then what will happen? 3d becomes 9. So 3d becomes 9. Check for the number of unpaired electrons. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 1 unpaired electrons were present. So if there are 1 unpaired electrons, even a unpaired electron is present, that exhibits color, because there is a chance for this electrons to excite, absorbing color and absorbing the energy. So therefore Cu2 plus I have written 1. So that means it is colored. It is colored. Now if I am going to talk about Cu plus, what will happen now? Cu plus means only s electrons will be removed. So D becomes how many electrons? 10 electrons. 10 electrons means here also 1 electron will be getting filled. So 3D becomes 10. So there is no unpaired electrons. There is no vacant d orbital. The electrons were completely filled. Since the electrons were completely filled, there is no chance for the electrons to go to the excited state. Though the orbital undergoes degeneracy, even then the electrons cannot go for excitation because it is completely filled with electrons. Completely filled, not off filled. I am talking about completely filled configuration. Is that clear what I am telling? So, color formation. Today in our class we have studied about the colored formation. So you have to tell me whether D block elements will form color or what? Yes, D block elements will form a color. So what is the reason why D block elements forms a color? Because of DD transition state. And second point is due to the presence of unpaired electrons, you can say, due to the presence of incompletely filled d orbital, due to the presence of vacant d orbital, whatsoever it is. But exact term is due to the presence of unpaired electrons. Due to the presence in your NEET examination, you can expect. So color formation now, immediately 2 points you have to keep it in mind. One is DD transition state, the other one is due to the presence of unpaired electrons. For DD transition only, I have explained you in such a way, and this you would have studied in the coordination chemistry under crystal field theory. The second one is due to the presence of unpaired electrons. So this titanium, you see, 1 unpaired electrons. Vanadium 3 plus 2 unpaired electrons. Chromium 3 plus is 3 unpaired electrons. Chromium 2 plus 4 unpaired electrons. Manganese 5. Iron, if you take 4 unpaired electrons. Cobalt 3 unpaired electrons. Nickel 2 unpaired electrons. Then again copper 2 plus is 1 unpaired electrons. Copper plus and Zn 2 plus, when you take, there are no unpaired electrons. So there, since there are no unpaired electrons, it tends to be colorless. Is it all clear? So I hope this class you would have understand, and every day you would have understood, and every day we will be having a class, and I will be dealing you with everyday one properties, and see to that you are studying thoroughly with the properties and you are understanding the concept, and provided whatever the question is being expected from that particular properties, and you must be in a position to answer, okay, for your competitive examination, NEET and JEE examination. And some of the examples and the explanations which I have given is away from the CBSE, but even then you must understand the concept, which will be very much helpful for you to compete with the NEET and the JEE examinations as well. So signing off, thank you so much. I am from Get NEET Academy. I am a faculty member for chemistry, and tomorrow again we will see. Thank you so much.